Hello, Algebra 1A students for Ms. Buchanan. This is January 4th. This is due on the 5th tomorrow. And it's just definitions. And she has on her site this dictionary where you can go through and get all these. I got the first one, coordinate plane. You would just go down and find coordinate plane, and then you would, where's coordinate plane? And then you would just copy the definition down. So coordinate plane is there, the first one, and you have an example there, and you could draw that, the plane containing the x and y axis. And that's what I have here, the plane containing the x and y axis. As I go through these, I'm going to go through the ones that are not on there that she said you could look up on Google, and then make sure you get the math definition. So I wanted to reduce confusion, and I got those for you. So the first one's done for you, and you could even have the example, like this. Here's your y-axis, here's your x-axis. There's arrows, it keeps going in both directions, negative and positive. 1, 2, 3, 1, 2, 3, and 1, 2, 3. You could, even number them 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. If you want to draw an example or a visual. Quadrants was a little bit confusion because I think it had something similar, but it wasn't exactly. I don't know if there was any quadrants. I think it had, maybe, I don't know. Anyways, quadrants is any of the four areas made when we divide up a plane by an x and y axis. And they're numbered. This is the first quadrant, and then it goes counterclockwise, so backwards. 1, 2, 3, 4. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? X and Y, that's in that dictionary. It's real easy. Just look them up. All of these are in there also, in that site that she has listed there. A discrete graph is not. And a discrete graph is a series of unconnected points. It's a scatter plot. And I have an example here. Just, you have your x and y axis, you have your coordinate plane, and you just have points just listed there. That's a discrete graph. A continuous graph are graphs that appear as one smooth curve with no holes or gaps. In parentheses I have, can be drawn without lifting a pencil. Okay, once again, pause this so you could write all this down. And here's my example. From this point to this point, I have one smooth curve. It's a continuous graph. All of these are not specifically listed in that dictionary that she has the link to. So a relation is an ordered pairs of x and y values. For instance, 1, 5, 2, 10, 3, 15. The domain are going to be all the x values in ordered pairs. So that would be 1, 2, and 3. These are all x, y, x, y, x, y. So all the x's would be 1, 2, 3. That would be the domain. And I'm telling you that that's from, the definition of relation. The y or the range are the y values in ordered pairs. So that's going to be the 5, 10, and 15 in my previous example. And then whenever you're mapping, it's any prescribed way of assigning to each object in one set a particular object in another set. So it might just be, drawing arrows. That would be a mapping. 1 goes with 5 in my example that I keep going back to. 2 goes with 10, and 3 goes with 15. That's an example. Function is in that link that she sent. All of these 5 up here are not in that link. So function notation is a way in which a function can be represented using symbols and signs. The most common function notation is f of x. And we'll get more into that later. Inputs are the x values in a function. So all of these are the inputs. So you put this in, you put it through a function, and this comes out. This is the output. The output are the y values in a function. And so that's, in my example that I keep going back to, would be 5, 10, and 15. Okay, you can see what the function is. you know, it's just multiplied by 5. Each x value is multiplied by 5. So that would be the function. So the input, you know, you put these in, you multiply it by 5, you get these, the output. The vertical line test. Okay, this is going to take a little bit of explaining. It's drawing a vertical line on a coordinate plane to see if a graph is a function. This line cannot hit more than one point to be a function. So in other words, this would be a function because if I draw vertical lines, notice I'm only going to hit, every time I draw a vertical line on one of these points, I only hit one of the points. I only hit one point. But see here, if I draw a vertical line, I hit 2 points. I hit 1 point, I hit 1 point, I hit 2 points. It's not a point, that's part of my eraser. I hit 2 points. This is not a function here because, you know, just because this one line here, I hit 2 points, vertical line. I also have an example here where I hit 2 points. So it's not a function. That's the vertical line test. You might even see them, lines drawn like a circle or something like that. So I draw a vertical line, I hit a point here, I hit a point there. That's not a function. Okay? Zeros. This is where the graph of a function intersects the x and y axis. It's the x and y intercepts. So when y equals 0, x equals, this might be 3. So that's going to be a 0. When x equals 0, y, maybe that equals 3. So let me go 1, 2, 3, 1, 2, 3. Okay. So this would be, this point right here is 3, 0. This point here is 0, 3. So those would be the zeros of this line. Okay. Everything else, arithmetic sequence, common difference, those are in there. Arithmetic sequence formula was not in that link, and here it is. I have an equals a1 plus n minus 1 in parentheses times d. Now, what do these mean? The an is the nth term, so whatever term you're looking for. A1 is the first term in an arithmetic sequence. N is the term position, and D is the common difference. So you would just write that down, and we'll be working with that, and it will make more sense once we start working with it. So remember to use that link that she had posted here with all of the definitions listed right there for you, and to get all the blank spots filled in. Good luck.